There we go. Chapter 1.4, now we're getting into quantitative data. Everything we've done in the past 2 days dealt with categorical data, putting you into a grouping. You're doing bar graphs or pie charts or side-by-side bar graphs or even the segmented bar graphs. Today we're now going to get into quantitative data. So we're going to deal with numbers. Now you won't necessarily need a calculator today, but you're going to need a calculator soon. Okay.
Did we skip this then and displays?
No, that's going to be the second part of the notes.
Okay. It's like.
Is it backwards?
Yeah.
Weird. So we're just. There we go. I got scared there too, because I was like, how is your packet different? I mean, it happens. I mean, once in a while something gets misstapled. So anyway, how do we go about, as it says up here, displaying and describing quantitative data? There are many different graphical displays. And these first few displays that we're going to do today, we're going to talk about dot plots and we're going to talk about stem plots. They're a great way to display data when you basically have a reasonably small set of data. If you have 100 data points or 500 data points, doing a dot plot or even a stem and leaf plot becomes so unbelievably busy work and cumbersome that you're better off doing a different display, which we'll show later on. So most of these that we'll be dealing with will be reasonably small sets of data, probably less than 30 data points or less. Okay? So one of them that we will do is simply called a dot plot. Right? And all a dot plot is you're going to have basically a horizontal measurement scale or a horizontal line with a scale on it. And above each value that is in the data, you'll put a dot above that location. Every time that a data point repeats, you're just going to start to stack the dots. So they'll eventually get stacked vertically. So your dot plot might look something like this. If I have the numbers like 1, 2, 3, 4, 5. Okay? Like if I say, rate Mr. Bartz on a scale of 1 to 5. 5 being a great teacher and 1 being a terrible teacher. So we'd be like having points right here, right? Okay, but you might have some scores like this. Okay, so this would represent 2 students gave them a 1, 3 students gave them a 2, 2 students gave them a 3, and so forth. Okay, so that's what it will look like. Okay, so just to get practice on doing a dot plot, let's take a look at what we have going on here. Okay. In this example, it says, here's the data on both yield and average maturity in days for the 10 largest tax-free money market funds, as reported in the January 4th, 2014 Los Angeles Times. Wow, some data that's only like a little bit more than a year old. Usually the data is like 20 years old. So, in question A, it says, construct a dot plot for the yield data. So, I'm just going to do it for this one right here. Describe the overall pattern of the distribution and any deviations from that pattern. So, we haven't talked about how to describe. So, let's just do the dot plot first, and then we'll talk about describing data. Okay? So, our dot plot, make a horizontal line. Okay? And down here, I'm going to label what it represents. It represents the yield. So now, what's at least nice about my data that they gave you here is it's at least in order from the greatest number to the lowest. So when I look at this, I need to go up to 4.8 and down to 3.6. So I'm going to start here at 3.6 and count by tenths all the way up to 4. Do I have to go to 4.8? 4.1, 4.2, 4.3, 4.4, 4.5, 0.6. Of course, I got to extend it just a little bit, 4.7, and 4.8. Now, for each and every data point I have, I want to put a dot above the number. So I have 1 at 4.8, 1 at 4.3, 2 at 4.2, or actually 3 at 4.2, 1 at 4.1, 3 at 4.0, and 1 at 3.6. Yes.
So like, would we have to put all the numbers in between, or would we be able to just do like the line with just the numbers on them?
Well, if you don't want to write every single number, I suppose you go like 3.6, 3, and do a dash, 3.8, do another dash. Oh, Mr. Bartz, did anyone notice that?
Emily did, we didn't say anything.
And you didn't say anything? Oh my goodness, I'm embarrassed. I'm gonna correct that part of the graph, and this is actually recorded. Oh, no! That's okay. I do this, and it comes, at least that comes back. Okay? I missed 3.9.
It gives me time to catch
I
up.
thought you were just doing something weird with your graph.
Well,
It's okay.
it's okay to question Mr. Bartz. I make mistakes all the time. I've probably made now 3 on this video. Is that better? Did I skip any other numbers?
Beautiful.
Okay, so
Oh man, someone might watch that video and go, what? All your videos have so many mistakes, Mr. Bartz. I don't even know why we watch them. Anyway, so we get a picture. That actually helps just a little bit. Now it asks you to describe the overall pattern of the distribution. Now we haven't given you any guides or reference on how do you go about describing the pattern. Okay? So I'm going to give you some basics right now, but when we get into, I believe it's going to be lesson 1.5, 1.6 tomorrow, we'll get even more descriptive. Okay? When we talk about the overall pattern, what we're going to want to talk about is these 3 things: the shape, the center, okay, and the spread. Okay? Now with the shape, okay, what we want to talk about is basically what does it look like, okay? With shape, there's a lot of terminology. For right now, I'm just going to give you 3 things to use, and then we'll talk about it a little bit more. Shape, we'll talk about it being, I can't spell right now, S-Y-M-M-E-T-R-I, symmetric, there we go. Symmetric has 2 M's in it, doesn't it?
Yeah.
Well, it does today, I guess. I'm all subconscious right now. That's not good. Symmetric, when we mean something to be symmetric, if we have a line of symmetry, what does that actually mean? Remember your geometry. Okay, it's equal on each side, or it's roughly balanced on each side. When we describe the shape of a distribution, we look at it and does the left side of the data look somewhat close to the right side of the data? Okay? Otherwise, we'll talk about skewed right or skewed left. The word skewed means tail. Okay? So what you can do sometimes is just draw a curve over the graph. Skewed to the right means you'll have a lot of data points that are low, and you'll have this little tail going to the right. Skewed to the left, you'll have a lot of high data points and a few low data points. So if I look at the shape of my distribution here, if I were to just kind of draw a little curve above it, what would you say? Yeah, it's fairly even. I mean, maybe a tiny skew to the right, but usually skewness you'll see a lot of points and a big tail. So in this case, if I were to describe the overall pattern, we'd say our distribution is fairly symmetric. Now, that's just the shape. Now with the center, lots of times we'll just right now talk about where's the middle located at? Where is the center, where is the middle data point roughly? We'll get more technical tomorrow. Where would you say it's located? Okay, 4.2, are you okay with that? Okay. Okay, so with a center around 4.2, since it's a yield, it's a percentage, 4.2%. And then when we talk about the spread, we state the low and high values. So right now we're saying our distribution is fairly symmetric with a center around 4.2 and a spread going from 3.6% to 4.8%. Now the last piece that's mentioned here is it says any deviations. When we talk about deviations, sometimes we'll talk about the word outliers. Remember your days in Algebra 2, at least if those of you who here took Algebra 2 here, remember how you classify outliers? We're going to do that again. But outliers are basically, or deviations, points that aren't like in the overall pattern. Are any of these points outliers? Okay. Maybe 3.8 and 4.6. So we'll just note that.
You got
So-
it backwards. 3.6 and 4.8.
Oh, did I do 3.8, 4. Yeah, I had my little dyslexia number moment. Yeah. All right, thank you for correcting me on that. So we could say 3.6% and 4.8% may be outliers. We don't know for sure until we do an actual calculation of it, but at least the pattern of it may suggest that. All right, let's continue on with the part B. It says, construct a dot plot of the maturity data. Describe the overall pattern of the distribution, any deviations from that pattern. I'm going to shrink this just a little bit to 100% so that I can at least see the data and the graph. What makes this at least a little more challenging? It's not in order. Okay? So we actually have to eyeball it and say, all right, what's our lowest value up here? 26. What's our highest? 71. Okay? Quick question?
What is spread?
Spread?
When you say spread, or is that spread?
When you wrote
Spread.
it, you wrote spread.
Like you spread peanut butter on your toast?
No, you wrote it wrong.
You said spread. After 4.2%.
S-P-R-E, well my A didn't, my A looks like a N, but it's supposed to be spread.
Okay.
Yeah. Sometimes what happens is, like when I'll write it, sometimes things don't get picked up, so I apologize.
That's okay.
I'll catch that, Amanda.
Can you scroll up just like for
Up,
5
or
seconds?
like this?
Okay, good, I'm done. That's all.
Okay.
Okay, good.
Alright. So, whoa, I didn't want to go that far. So 26 to 71. Now here's where doing the dot plot, boy, if 26 to 71, I gotta write like 50 numbers. Okay, this is where, when doing a dot plot, writing the 50 numbers might not be the greatest thing or you'd want to do. So here's maturity. What I might do is start at 25, leave spaces, and count by fives, but I'm not going to put in all the dashes. So I'll go 30, 35, 40, 45. See, it didn't write that whole 4 there. 50, 55, 60. I got to extend this even farther. 65, 70. If I leave a little space, I'll get the 71. Now the hope and goal of the dot plot is just to kind of get a picture of what's going on. So now I can just start doing each of those points. So 26, 64, come on dot, pop up there. 63, so that'd be one right next to it. 48, 71, 37, 55, 64, that's a repeat, 50, and 48. Was 48 a repeat also? Yes, it was. So now when I look at the pattern of this data, if I draw a curve over it, could we at least give this a little bit of skewness? Or is it symmetric? Okay. You know, if you said it was fairly symmetric, I suppose it's a little bit hard to argue it. I would lean more towards it being a little skewed to the left. Mainly because if I'm kind of drawing a line of symmetry here, okay, right down the middle, okay, it looks like I got a little more spread going this to the left than I do to the right. So I might say our distribution is slightly skewed to the left. So our distribution is slightly skewed to the left. I can say with a center around $50 sound good? Or do you want something else? 50? Around 50. And what does the units on the 50 of the maturity? Is it months or years? Days. Maturity is in days. Around 50 days. And a spread let's see, make sure it picks up the A there, or the going from so my low was what, 26? 26 days to 71 days. Do any of these appear to be outliers? The one that's representing 26, definitely more than 71, so I might just stick with 26. 26 days may be an outlier. All right, are we okay with dot plots? not too hard, just, you know, a little bit of busy work. Lots of times when you have data sets that, in our case, we only had about 10 points. Not pretty quick to be able to do. All right, let's go to the second page with stem plots. Yes, Emily, yes, I can go back.
And just scroll up a little bit.
Really good. Oh, okay, good. I got it. Okay, good. I was making sure I got it.
Okay. Do you still need, can I go to the next page?
You're good. You're good. Thank you.
All right, so now,
Yeah.
a stem and leaf display, right, is a nice way that you can display, again, another set of data. It's kind of like a dot plot, but instead of having an individual dot for each and every point, what it starts to do is it will start to group data in stems, and each dot will, in essence, be the leaf. But we don't use dots, but we actually write the numbers. So what happens in a stem and leaf, as it describes here, is the data is going to be broken into two pieces. You have your stem and then your leaf. The stem, okay, is going to be the first part of the number, and it consists of the beginning digit or digits. Okay? Because if you have like a 3-digit number, right, you'll actually use the first 2 digits, or you'll use the tens and the hundreds digit as part of your stem. The leaf will consist of the last and final digit. So what might happen is I might have a data set here where I have like the number 123. What will happen is we'll divide the data into the stem and then the leaf. So what will happen is I'll write the number 12 here as part of the stem, and then the number 3 here as the leaf. So this represents 123. So if I have also the number 125, what I can do then is just put a 5 here. So I have 123 and 125. Okay? So it allows you to start to put your data together. So if I have the number now also like 131, I can put a 13 here with a 1. So that represents 131. Okay? Now what sometimes will happen is you might be saying, well, geez, what if I have like a range of digits? One of the things that you can do that will be mentioned here is you can round your data points. So it makes it a little bit easier to create your stem and leaf graph. And I think one of the examples will ask you to round it. Okay? The key with the stem and leaf is to get your data in order and be able to give you a picture of what's going on. Okay? So here's basically the 4 steps that you want to do. Okay? So the first step says here, just select 1 or more leading digits for the stem. The trailing digit again becomes your leaf. Note here, this is kind of the big key piece that can help you a ton. You might have to round your data to help with your construction. Okay? You'll list all your possible stem values in the vertical column. Now it says you may have to split the stems to get a better idea. I'll show you how that works in this example about splitting the stems. Then you're going to record the leaf for every observation, okay, in numerical order. So you'll go from smallest to biggest. It's nice when you have them listed from smallest to biggest because then your data's in order. It'll help you later on when we start finding quartiles and stuff. The last thing you need to do is give a key. So like here I give you a stem and leaf, but over here what I'd want to do is write a key where I might do something like this. 12.5 means 125. So the reader knows exactly what the data points represent. Okay? So to show you how we can do this, okay? Let's take a look at this example here. It says, below are the test scores from a recent exam, 50 points on this exam, given in Mr. Bartz's first hour Algebra 2 class. Okay. So Some of you who had me for Algebra 2 might see some of your scores on a 50-point test. Hopefully you're up here. Okay? What's at least nice about how Mr. Bartz gave this data? It's in order. Okay? So one of the things that I'll eventually do is, when we have a larger list of data points that's not in order, one of the things you can do is type them in your calculator and sort them. And then you can look at your calculator, because I think it's a lot easier doing these graphs when the data is sorted. So now, question A says construct a stem and leaf plot. So what do we want to have be our stem? What digit's going to be our stem?
First digit.
Okay, our first digit or our tens digit. And then guess what's going to be the leaf? The ones, or the last digit. So if I look here, our scores go from 16 to 50. So when I'm thinking about my stem, I have scores in the 10s, the 20s, the 30s, the 40s, and the 50s. So now, for each score that's in the 10, I'm going to write the ones digit. So here a 16 was my only one, so I'll just write a 6. So then when I do the 20s, I have 22 and 28, so I go a 2 and an 8. Now notice, I don't put a comma. I don't need to put a comma, because I know that this represents 22, this represents 28. I now do the 30s. So I have a 0, a 2, a 4, a 4, so I repeat the 4s, a 6, a 7, 2 8s, and a 9. So yes, we have lots of numbers there. I now do the 40s. So I have 2 zeros to represent the 2 40s, a 41. Another 41, 2 42s, 2 43s, 2 44s, 2 45s. Whoops, helps if I write a 5. So I got to do 2 45s, 2 46s, a 47, and a 48. Wow, that string of numbers got pretty long. And then I do my 50s. Yeah. Not right now. When I'm done with the lesson, I'll be more than happy to give it to you. All right, B. It says construct a second stem plot. Ooh, what did I forget to do with the stem plot here? I got to write a key. So when I do a key, I just pick any of the points. So I might go like this. 3/4 means a score of 34 points. That way the reader understands, and I might write this slash a little bit bigger so you're not going, what's 3/14? Now it says to split the stems, okay? If you think about how these stems work, this is all your numbers 10 through 19, 20 through 29, 30 through 39. So they're kind of groups in tens, aren't they? So what I can do is break it down instead of groups of 10. If I break it in half, I'll have groups of what? 5s. So when I split my stems, what will happen is I'll break up my 10s. Now notice that my lowest score is 16. That would be in the upper half of my 10 scores. So I only have to put 1, 2, or 1, 1. But I'll put 2 2s, 3 3s, I'm sorry, not 3 3s, 2 3s, 2 4s, and 1 5. Because I'm going to split my 20s, my 30s, and my 40s in half. I'm really splitting my 10s in half, but I only have to write 1 because my lowest score is in the upper half. If this score was a 14 or like a 12, I'd actually have 2 1s here. Or if one of these scores was like 56, I'd put 2 5s. So what happens is when you split the stems, okay, you're basically splitting the scores to 0 and 4, 5 to 9. Because they each will have 5 scores in them. Okay, you have 5 scores here from 0 to 4. A lot of students will go 0 to 5 and 6 to 9, but you actually have 6 scores to 4 scores. You want to keep them even. So now I rewrite the numbers according to their split stems. So this would be 16. We'd have 22. The 8 does not go here, but it goes into the next stem because it would be between 5 and 9. So what now happens with my 30s is now I'll have 0, 2, 4, 4, and then I'll have 6, 7, 8, 8, 9. When I do my 40s, it's really nice because it splits this really long line, not quite in half, but I'll have a bunch of 2 0s, 2 1s, 2 2s, 2 3s, and 2 4s. The 5s go in the next one. So the 2 5s, the 2 6s, the 7, and the 8. Because this would be between 40 and 44, 45 and 49. They'll each have 5 numbers in them. And I have the 2 50s. So now, the second part of question B asks, which plot shows the shape of the distribution better? Well, if you look at this, if I look at the first one, and I kind of draw a curve over it, and I turn it on its side, which I can't do with the screen, but you can do that with your paper, how would you describe this one? Okay? Maybe just a little bit skewed to the, okay, which way does the tail go? If I were to kind of finish that a little bit. If you turn it on its side, it's actually going to the lower scores, which would maybe be slightly skewed to the left. But what does the split stems do for you? Does that show the skewness a little bit more?
Yeah.
Yeah. So which of these two shows the skewness a little bit better? Okay, the split stems. So sometimes it's very good to split the stems. You'll see the distribution better. So which of the plot shows the shape of the distribution better? The split stems shows that the distribution of scores is skewed, excuse me, skewed to the left, which is good. At least as a teacher, I'd like to have skewed to the left scores because that means I'm going to have many more higher scores than lower scores. Nicholas, you had your hand up?
Yeah, so when we have it on a test, would it tell us if we need to do a split stem or just a regular one? Or is it just like a reference?
Well, part of the reason why I would consider splitting the stems here is, one, I only had 5 stems here, and I'm only going to have like 5 sets of data, or 5, if you almost want to think of these as like lists or 5 bars of data. It's not really going to paint the picture very well for me, as when I split the stems, it gave me 8 bars, which kind of started to spread it out a little bit more, gave me a better picture of it.
So should we like always split it?
It depends on the data.
Okay.
On this one, I probably would have, since a lot of the data was condensed between, you know, basically 5 sets of numbers. I mean, if this was a 100-point test, and I had scores going from 30 to 100, I might not. Okay. It might get, and if I, had, I don't know how many test scores we actually had here. Was it about 30? I might be able to get a good picture of it. Okay. So, last thing, and then we'll switch to the CFU here. It says, write a few sentences describing the test scores from Mr. Bartz's Algebra 2 class. So let's talk about, shape, center, and spread. Okay? So anytime it talks about describing, I'm going to start talking about shape, center, and spread. So we can say the distribution of Algebra 2 test scores are skewed to the left with a center around, where does it seem to be centered around? So where does the middle score roughly appear? Are you okay with, I heard someone say 40. Are you okay if we said 40? Does it seem like that's about the same number of scores above and below it? No? I heard someone say no. What would you like to go with if who said no? You want to go with 42. Okay? Okay, 41. See, this is where we can have some discussion. I like that. Okay? So, this is where we would, since we're using a round and we're not using an exact measurement, I probably would allow you to say 40 or 41 or maybe even 42. I think 42 might be a little extreme. So I might go right in the middle of compromise and say around 41 points. Where does the spread of scores go from? The spread of scores goes from, the low was 16 to 50 points. Any of these scores seem to be an outlier? Okay. 16? A score of 16 may be an outlier. Cool. All right.